Okay. So now you read out another numerical, that is 12.7. I'll write down on the board what it is telling. Okay.
A steam engine
Please be
delivers
little louder. Yeah.
a steam engine delivers 5.4 into 10 power
Slowly. Yeah. Steam engine delivers
5.4 into 10 power 8
uh,
joule of work per minute
joule per minute. Okay.
and serves
Slowly.
and services
Uh,
3.6 into
hmm.
10 power 9 joule of heat per minute from its boiler.
Services means what? A steam engine does 5.4 into 10 to the power 8 joule per minute of work. Okay. Then what is next?
And services 3.6 into 10 power 9
Ah.
joule of heat per minute from its
Joule of heat per minute
from its boiler.
from boiler. From boiler. Okay. So heat taken from boiler. Okay. So your heat taken from boiler is this, and steam engine produces this much of work. Produces work. Okay. That is that. Okay. Okay. So this heat from boiler is Q. Okay. What is next?
What is the efficiency of the engine?
Okay. What is the efficiency of the engine? That's the question.
How much heat is wasted per minute?
How much heat is wasted per. That's the question. Okay. A steam engine delivers 5.4 into 10 to the power 8 joule of work per minute and services 3.6 into 10 to the power 9 joule of heat per minute from boiler. Okay. So, you know what is efficiency. Okay. So, efficiency. So, what is a heat engine? A steam engine. Steam engine is a external combustion engine. Okay. So, in external combustion engine, you have a boiler. Okay. You have a boiler. Inside the boiler, your coal is burning. Okay. Inside. So, let me say this is a boiler. Okay. This is my boiler. Okay. So inside this boiler, you have some coal burning. Okay, some coal burning. Okay, then let us say there is some water here. So this water will get heated and steam will get produced. So from this boiler, this steam will with the help of a pipe, the steam will go. Okay, so this steam will go to the, let us say it will go to the engine, right? Normal same piston engine or whatever. So only difference between the steam engine and your internal combustion engine is that in internal combustion engine the combustion happens inside, but in steam engine the combustion is happening here. Okay. So so this steam is getting supplied here, and this steam goes to this piston cylinder assembly. It goes to the piston cylinder assembly. You have a connecting rod, and then this connecting rod, then you have a shaft. This connecting rod will be changing position like this, and you have a shaft. Right? Right? So that's how. So this boiler, actually there are different types of boilers. See, in any power plant, the major component is a boiler. Okay. So let us say in TTPS power plant or NTPC power plant, they have big boilers. So what are the raw material for boiler? Like the water from the river Brahmani, that is the one raw material, because we have huge amount of water available there. Also the coal that we get for the Mahanadi coal field or whatever MCL, that is another raw material. So because we have coal and water, that's why we have a power plant there. Okay. So this boiler is an important part of a power plant. So this steam, in case of power plant, like in the train and all, it is driving a piston cylinder assembly, and then finally it is connected to the train wheel, and the train is running. Okay, but in case of power plant, you have a boiler. It will generate steam and it will drive a turbine. Okay, that is a steam turbine. Okay, turbine is something which will give work. So high pressure, high temperature steam will hit the turbine blades, and that high pressure it will become low pressure, low temperature steam and give out some work. So that work will be work. So that high pressure, high temperature steam after hitting the turbine blades, it will rotate the turbine blade. So turbine is something which will give work. Okay, compressor is something which takes work. So that turbine gives work, and then the turbine starts rotating, and then it will be coupled with generator, and generator produces electricity. So how does a power plant look like? Like normally turbines are shown like this. Okay, like because expansion of steam happens there. That's why it is a diverging. It is diverging like this. Okay, so this is your turbine. Okay, so to this turbine, your steam is coming. Steam from where steam is coming? Let us say it is coming from boiler. Okay, so from boiler, your steam is coming and hitting the turbine blades. Okay. So, when it hitting the turbine blade, it will give out some work. Okay. So this turbine is coupled to a generator. Okay. So now you have a generator. Okay. So generator produces electricity. Your generator produces electricity. So this generator will produce electricity at certain voltage. Okay. So that voltage again, what they will do at the power plant, they will step up that voltage, whatever they are getting. So they will step up that voltage, and that stepped up voltage through power transmission line will be sent to the grid. Okay, like say from power plant, let us say in our district it will go to from thermal power plant or from Pania, or it may go to Contabania grid. Okay, so the whole power generated will go to the grid. Okay, so from grid it will go to different places. Okay, so there will be in your village, like say in our the end of the village you have a transformer. So that transformer, that transformer will, let us say it will be 11 kV transformer. Okay, so that 11 kV transformer will step down the voltage from 11 kV to 220 volt or 440 volt. Okay, so that is called a step down transformer. So your transformer will have primary winding, your transformer will have secondary winding. So primary winding will have N1 turns, secondary winding will have N2 turns. So depending on N2 by N1 is greater than 1 or less than 1, you will call it as a step up or step down transformer. So you that N1 V1 is equal to N2 V2. That is the principle of transformer. So, uh, while explaining steam engine, I have just touched this. What are the different components of a power plant? A boiler. Boiler produces steam. Steam drives the turbine. Turbine gives some work. So this it will rotate this shaft actually. This will rotate the shaft. So this shaft is coupled to the generator shaft. So generator generates electricity. So you know Faraday's law. This generator, when a rotor rotates inside a starter, which produces the magnetic field. So inside a magnetic field, if a rotor rotates and it has conductor in it, so a conductor rotating inside a magnetic field will produce current. That is Faraday's law because of electromagnetic induction. So the generator is nothing but a circular arm. It has a starter, and it has a rotor. It has a rotor. So this rotor will have different conductors, current conductors. This rotor will have. Okay. Why it is starter? Because this body, this is static, whereas this is rotating because it is coupled to the turbine. Turbine is rotating, rotor is rotating, right? So you might have heard about in your electricity, the armature and other things. So this is the rotor. So generator has a starter, generator has a rotor. So this is complete generator. Okay. So generator has a starter, generator has a rotor. The rotor rotates inside the magnetic field. This starter will have different magnets like this. It will have magnets. Okay. So it will have magnets. Okay. So it will have magnets. So inside it will be producing a magnetic field. So when a conductor rotates inside a magnetic field, it will generate current. So that current will have certain voltage and certain amperage. So in the power plant, that voltage is very low. So that voltage has to be stepped up, and then it will be supplied to the grid, and from grid it will go to the different villages or towns for industrial or domestic usage. So just to give an example, in our village, the transformer input voltage is 11 kV, which is stepped down to 220 or 440 volt. If this 220 volt is your single phase, 440 volt is your three phase. So for suppose you want to drive a 10 HP induction motor, there you need 440 volt for industrial purpose. But for you like domestic use, maximum you need a fridge or a small 1 HP motor. So that we can use a 220 volt for that. Okay. So you can take a picture of this. So I have told you like what are the different components of a power plant, a thermal power plant. I have not told you about hydro power plant. Okay. So in a thermal power plant, the different components. Main thing is boiler. The raw material or input for boiler is water and coal. So the coal burns and it produces steam. That steam will be of high pressure, high temperature steam because of heat supplied from coal. That high pressure, high temperature steam heats the turbine, produces some work. The turbine shaft rotates. So once the turbine shaft rotates, the turbine shaft rotates and it is coupled to the generator shaft. The generator has a rotor or armature which has a conductor installed on it. So when it rotates inside a magnetic field, because of Faraday's law of electromagnetic induction, current will flow through the conductor and it will have certain voltage and amperage that will be using a transformer. The voltage will be stepped up and then it will be sent to the grid, and from grid again it will be sent to the different uh, villages or towns for their domestic use. So now on the question is a steam engine, it produces this much of work. Okay. Now the steam engine takes this much of heat. Okay. So now our question is, what is the efficiency? Okay, efficiency is nothing but work done divided by heat input. Heat input. Okay. So how much is the work done here? W I have told 5.48 into 10 to the power 8 joule per minute. Actually, it is not work, it is work done per unit time. Okay. So if both are of same unit, no problem. Okay. So this is a work done. Then how per minute, how much of heat it is taking from the boiler? 3.6 into 10 to the power 9 joule per minute. Okay. So if you simplify it, it will become, let's say, uh, okay, 5.4 and divided by 36, and this will become 10 to the power 8 divided by 10 to the power 8, and joule per minute divided by joule per minute. So this cancels. Efficiency is a unitless number. Yes. Okay. So it becomes 5.4 by 36. Okay. So 18 3 ja. So uh, this becomes
3 by 0.3 by
point 3, right? Point 3.
by 2.
No, 18. Okay. So let us say in the denominator you have 2. 18.
5.4,
Okay.
0.3, sir.
So 18 into 0.3 is equal to 54. It is 5.4. Okay. So
0.3
it
by
is
2.
0.3 by 2. Okay. So 0.3 is nothing but 3 by 10 into 2. Yeah. So 3 by 20. So 3 by 20. So 3 by 10 is nothing but your 30%. Okay. So 3 by 20 is nothing but your 15%. Okay. So the efficiency is just of the steam engine is just 15%. Okay. That is your efficiency. So efficiency of steam engine is 15% only. So you can imagine how much of heat we are able to convert to work. Okay. Then what is the next part of the question?
How much heat is wasted per minute?
Okay. How much heat is wasted per minute? Okay. So we know, as per first law of thermodynamics, it's nothing but conservation of energy. Okay. So uh, so Q1 minus Q2 is equal to W. Okay. Okay. So uh, so W I know, right, and Q1 I know, right? Q1. This is whatever heat is taken, that is nothing but your Q1, right? So it is something like this. So your Q1 is Q1, W, Okay. So it is something like this. The heat engine. You have a source. You have a source. You have the working substance. You are taking Q1. That means this is the boiler. You are taking Q1 and you have steam here. You have steam here. You are giving away Q2. Let us say you are giving away the heat to the atmosphere, and it is doing some work. What is that work? By driving the piston and rotating the wheel of the train, that work is being done. Okay. So we know, like, always remember that, because it comes from first law of thermodynamics. Del Q is equal to del U plus delta W. Right? Del U is zero here because it is a cyclic process.
Yes.
So it becomes Q1, del Q is nothing but Q1 minus Q2 and is equal to work done. This is very important. Q1 minus Q2 is equal to work done. Okay, so now the question is, how much of heat is wasted? That's the question, na?
Yes.
So my 3.6 or 36 into 10 to the power 8 minus U2 is equal to your W. How much is your W? Work done is 5.4
into 10.
Okay, 5.4 into 10 to the power 8. So Q2 is equal to 36 minus 5.4 into 10 to the power 8. Right? So that is the heat wasted. So much of heat is wasted. Like something, it is something like 30.2. No, 30.6. 30.6 joule per minute of heat is wasted.
Into 10 per 8.
Into 10 per 8. Okay. What is the next part? That's all. Okay. So, okay. Just see in the answer what is the efficiency, whether it is 15% or not. And what is the heat wasted, whether it is 30.6 or not. Correct, no? So 15% is your efficiency and 30.6
10 per
joule.
8. Here they've
30.
given 30.1, 10 per 9 in terms of 10.9.
Okay, that's fine, no problem.
Because we took 36 into 10 per 8
Okay.
for simplification.
That's fine.
They've
Fine.
kept it in 10 per 9.
That's fine. That's fine. So it is matching with the answer. So the whole idea here is to uh, understand the concept of efficiency and important thing Q1 minus Q2 is equal to W in any engine because it goes through cyclic process. So you forget about change in internal energy. So heat taken minus heat rejected is equal to work done. That's all. So here you can see that steam engine is very, very inefficient engine, just 15%. Okay, that means so much of heat you are wasting, like such a inefficient engine. That's why they have now from steam engine, the railway has moved to diesel engine first. So diesel engine has better efficiency than this steam engine. So so always with the improvement in technology, they always try to increase the efficiency. Okay, efficiency means the ideal thing is you want to use whole of your energy, 100%, but that is not possible as per second law of thermodynamics. So we have to maximize it. So first they found steam engine, that industry one, that industrial revolution one. So using steam engine, not only they were driving trains, they were doing many other works also, like driving a motor, driving a rice huller or whatever. So those are like now in railway they have replaced the steam engine by diesel engine later. Okay. Then after that, now in place of diesel, they are running it by electricity. They are running it by electricity. So electrification of railway is going on. Okay. So that so the main thing, any numerical, this is the driving equation for heat engine. They will be giving what is the work, heat input, what is the work done. The n number of questions can be framed out of this. So if you are clear about the concept, if you remember the formula correctly and understand each and every term of the formula, you can do hundreds of numericals. So doing numericals is not a big thing. Big thing is understanding the formula. If you understand the formula properly, you can solve n number of numericals. So try to understand the derivation and importance of each and every term. Okay. So that's we have solved one numerical on specific heat. Okay. Now you have the question was how much heat is required to raise the temperature of nitrogen by 45 degrees centigrade. That is one numerical. That is on specific heat at constant pressure. Earlier we have discussed about specific heat of solids where there is nothing like Cp and Cv. Here we have something like Cp and Cv in gas. So Cp minus Cv is equal to R. That you have to remember. Remember.
Cp is equal to 3R.
Cp is equal to 3R. That is important. That is, and also Cp minus Cv is equal to R.
Both are given and
both. So
one is given and R is on
yeah,
R.
Cp is equal to 3R. So in that case, they are giving you R, but you did not know Cp. So you have to multiply it by 3 to find out the
They
Cp.
can give you Cp,
So,
R, you have to
so
find
every chapter to be successful in your entrance, every chapter will have 5 to 6 formula. So after derivation, you have to write down the formula in those chapters. Okay, so when we are trying to do it, we are struggling. Okay, what is Cp is equal to 3R? They have given R, but how to find Cp? We have to refer it. So if for to do well in the entrance, if you remember all those things, immediately you can do it and save your time. So now for MCQ type of questions, it is very important that you remember, you understand the derivation first, but you remember the formula, those should be in your fingertips. But without understanding the derivation, it is very difficult to remember the formula. So understand the basics first, then memorize the formula, because that is what is essential nowadays, memorizing the formula so that you can solve some numerical. Okay. So with this, we have done another numerical based on heat engine. Then after that, we will do another numerical on the refrigerator. So we will cover heat engine, we will cover refrigerator, and in this numerical, while serving the numerical, I have explained you what are the different components of a power plant, what is boiler, what is generator, what is transformer, what are the things they are doing. So all those things I have, and also while explaining the nitrogen, I explained you the what is proton, what is neutron, what is nucleus, and if the atomic number of nitrogen is 7, how its molecular mass will be 28. So 28 and 1 mole of nitrogen will become 28 kg, 28 gram or whatever. So that also I have explained. Okay, so to do a numerical, you have to have understanding of many other things also. Just by understanding that chapter is not enough. You have to have a broader, like system level understanding of the things. Okay, so we'll do a refrigerator problem next. Okay. Thank you.